Okay, and good evening, everybody. I hope everything is going well for you. Uh, if you remember, I gave you an example last week, and I asked you to complete this example and send to me. Unfortunately, only one person sent to me email and sent to me answer of this example. So today I want to Today, I want to complete this example and review together the topic of forecasting, and also start some example about forecasting to for the better understanding about these topics. And after that, if we have enough time, we can start the new lessons. Other than, we can postpone it to next week. So if you remember, we solved three methods of this example last week, and we did it by using of the method of max, maximin, and regret. If you remember, only two methods have remained for uncertainty, and method of Howard and method of equal likelihood. So at the moment, we want to solve this problem by use of the Howard. I give you alpha equal 0.3 for situation 1. Unfortunately, I'm so sorry. Unfortunately, I forgot to say you this alpha is for situation 1, and the this alpha 0.2 is for situation 1, and alpha equal 0.5 is for situation 2. Please write this now. Alpha equals 0.5 is for situation 2. Okay. Everybody understand? Alpha equals 0.3 is for situation 1, and alpha equals 0.5 is for situation 2. Okay. The you should guess this. You should calculate the alpha for situation 3 yourself. When the situation 1 is when the alpha for situation 1 is 0.3, and for situation 2 is 0.5. So for situation 3, alpha is equal to, who can say? It's very clear. No, no.
I think it will be the average of both.
No, be careful. No, no. When the alpha for situation 1 is 0.3, and for situation 2 is 0.5, for situation 3, very good. Very good, Mr. Ismail Ibrahimi. Very good.
Could you please tell us how you find this number?
Dear friends, please turn off your microphone because it makes very noise. Please turn off your microphone, everybody, please. Okay, thank you so much. The alpha equal is 0.2 because the sum of the alpha should be equal 1. Okay, when the alpha for situation is 0.3 and for situation 2 is 0.5, so for situation 3 the alpha is equal is 0.2 because the sum of the all of the alpha should be equal to 1. 0.3 plus 0.5 is equal to 0.8. So 1 minus 0.8 is equal to 0.2. It's for situation 3. Yes, the total should be 1. Exactly. Now, with regard to this alpha that I gave you, I want to give you few minutes to solve this problem by use of the Howard's method. Okay, everybody do it now, and after that, I want to pass microphone to you to discuss together. I give you few minutes to solve this problem. Only Howard's by use of this alpha. Okay, will everybody do it now? All of you have the slides. Okay, you can refer to slides and see the Howard's, and by use of the slides, you can help. You can being helped by slides. No, no. The coefficient, the alpha for situation 1 is 0.3, for situation 2 is 0.5, and for situation 3 is 0.2. For all of them are not equal. I'm giving time to friends to solve this problem by use of the Howard's by use of Howard's method. Only Howard's. Okay, please solve this problem and say which project is suitable. Alpha for situation 1 equal to 0.3, for situation 2 is 0.5, and for situation 3 is 0.2. Please do it now. Yes, that's right. Yes, exactly. Okay, everybody has solved this problem. If anybody has solved, let me know, please, to talk about that for other friends. Mr. Diaz, you want to talk? Okay, Mr. Diaz, your microphone is free now. You can talk. No, I want to know anybody has solved this problem by use of the Howard's method. If anybody has solved this, please discuss about that for other friends. This example that you can see on your screen. Okay, Mr. Jesse, please talk for other friends. Okay, thank you. Your microphone is free now, and you can talk. Mr. Jesse, I can't hear your voice. Anybody can hear Mr. Jesse?
I think we also don't hear her voice.
Mr. Jesse, I think your microphone has problem because also other friends cannot hear your voice. Mr. Jesse, I have free I have made free the microphone for you. Your microphone is free now, but we cannot hear your voice. I don't know. I think the problem is on your side, from your side, not from me. Okay, no problem. You know. Anybody, somebody else wants to talk about that or not? That's it, but you cannot talk yet. Okay. That's it, Master Safi. You want to talk? You're doing right. If you want, I can make free microphone for you and talk about this method for your friends. Okay. Who wants to talk? Who wants to talk about this problem for others? Okay. Please let me talk about that. As I told you, the Howard's method is related. It involved to and identifying the alpha. The alpha can be identified according to experience by operation manager. When the alpha is determined by operation manager, and they can solve this problem by Howard's method. Howard's method is one of OSA 5 methods in relation to uncertainty situation. We talk about that each situation or each nature of can be allocated by one alpha. For example, for project one, I told you the situation one, the alpha for situation one alpha is alpha equal to 0.3. For situation two, alpha equal to 0.5, and for situation three, alpha equal 0.2. The sum of the alpha should be 1, should be equal to 1. So 0.3 plus 0.5 plus 0.2 is equal to 1. For project 1, in situation 1 should be multiplied on alpha, on its alpha. Situation 1 for project 1 is 23,000, multiply 0.3 plus situation 2, 34,500, multiply alpha 2, that is 0.5, and situation 3 is yes. and situation T is 27,000 multiply 0.2. As you see, most of your friend has done like this, and you can see in chat frame. Uh, when you see Mr. Masood Safi has done it, and you can see for project 1 you should calculate this number, and also for project 2 you should calculate, you should do the same, and also for project 3 you should do the same, and after that you should choose the maximum. When you choose the maximum number determine which project is suitable. Uh, Very good. Yes. As Mr. Akmal, Mr. Masood Safi has done this, you see the project 1 has the maximum number, so the project 1 is suitable for this situation. Now we should do it for equal likelihood. The last method in uncertainty is equal likelihood. Okay, please let me see together this method, equal likelihood criteria, as you see. In equal likelihood, if you remember, and also we have alpha, but the alpha for equal likelihood should be calculated by yourself. Okay, we have how many states of nature we have here? A state of nature, and we have two states of nature here in this example. So one divided by 2 equal is 0.5. Yes, as you see. 1 divided by 2 is, so in each project, each of states of nature should be multiplied by 0.5, because we have two states of nature here, and so 1 divided by 2 is equal to 0.5. This is the equal likelihood. Equal likelihood means that for each of the states of nature we should have the same number for alpha. The alpha are the same for all of the states of nature. So this is the reason we divided 1 by the number of stages. The states of nature is 2, 1 divided by 2 equal to 0.5. So each of the states of nature in each situation, in each project should be multiplied this number 0.5. Now in this example, in our example, in slide 16, how many situation or states of nature we have here? How many? 3. Yes, we have 3 situation or states of nature. Exactly, we have 3 here. So the alpha is 1 divided by 3. Very good, Mr. Barak. Exactly. So the alpha is equal here. Alpha is equal is 0.3 or 0.33. This is not very accurate, because the 1 divided by 3, as you see, cannot produce a frank number or a right number. Approximately, exactly, Mr. Barakat. Approximately, it can calculate it by 0.33. We can we can take it 0.3. 0.3 is enough. Okay, we can take it 0.3 for um, to make it easier or calculation to make it easier or calculation. So um, each of situation in each project should be multiplied to 0.3. For example, in project 1, situation 1 multiply 0.3 plus situation 2 multiply 0.3 plus situation 3 multiply 0.3. Give a number for project 1. For we can do it for project 2 and project 3 the same. Yes, very good. Everybody has understand or explain again. This method and Howard's method are the same, but in the Howard's method, each situation has its own alpha, but in the equal likelihood, because from its name is clear, the name is equal likelihood. It means that the alpha is equal for all of the situation. How it should be calculated, it depends on the number of the situation or states of nature. 1 divided by number of states of nature give you alpha. And we, after calculating alpha, we do it the same as Howard's method. No, Mr. Akmal. Mr. Akmal, this calculation is for has been calculated based on 0.5, but the alpha is 0.3 here.
Sir, I just multiple. I think I just multiple all with the
Uh-huh.
zero point 0.5, not with the 0.2. So I think the result will be just project 1 because it is with 1,450. But let's see it from our.
Uh-huh. But I know, but this calculation you have sent in this chat frame has been calculated based on the no, alpha is no, alpha is 0.3. Alpha is equal to 0.3 because we exactly, Mr. Qiyasi. Mr. Qiyasi is right. We have three situation or three states of nature. So 1 divided by 3 equal to 0.3. Alpha is 0.3 for all of the situation. So all of the situation is exactly the same. Okay, everybody understand? Okay, very good. If somebody don't understand, please let me know to explain again. No. For calculating alpha, we should divide 1, number 1, okay, 1. 1 divided by number of situation. 1 divided by number of situation. Yes, yes, we can have more than 3 situation. We can have 5 situation, 2 situation, 4 situation. It depends on the situation that operation manager wants to analyze it. This is in hand of the operation manager. Operation manager, according to his experience, can divide it, can make several situation, can make several for example, if you want to calculate more accurate, okay, if you want to calculate more accurate, and you can use the more situation. For example, you can sell the excellent. For example, excellent, very good, uh, neutral, and for example, weak and very weak. For example, 5 situation. If you want to if you want to calculate more accurate. Okay. Okay, if anybody has understand this, please let me review the forecasting and solve some problem about the forecasting together, okay? Yeah, very good. Thank you so much, Mr. Eichmann. It's very good. Okay, please let me open the slide of the forecasting and review it very quickly.
Sir, could you please share the slide? We don't have slide, I think.
Anybody can hear me?
Yes, I think we can hear you.
Unfortunately, I don't know what's the problem with. Yes, I don't know what's the problem for the website. Unfortunately, again, like the yes, I know. The problem is I'm saying when I want to share the slides, it cannot open. I don't know why.
When sometimes the internet is getting slow, it's also bring the same problem to the host, I think. So it's possible to allow some other one to display the slides because we are just wasting our time.
دلبرا گرزیان
Mr. Razi, could you please match your wife?
Anybody can me? Anybody can hear me?
Yes, too.
Uh, I don't know what's the problem. I can share. I can share the slides. I don't know what's the problem. It's not for my computer because I restart my computer and but the problem still exists. I don't know.
So it's possible to allow some other one to display the slide.
Pardon?
If you give chance to other one to display slides and you will for explaining.
Uh, Please let me.
I think today my internet is working well. If you send me the slides, I will share the desktop.
Okay. Mr. Yossi, do you hear me? Mr. Yossi, I want to pass you host. Okay. Mr. Yossi, please, please host for a moment. I should log out and okay, and after that login. Yes, I can pass the host to somebody else. Mr. Yossi, if you can, I want to pass you host. Okay, please be host for a few minutes. I should log out and then log in. Okay. Now you are host.
Hello, do you have my voice, please? Hello? Okay, that's good. You see, this is not the problem from my computer or mic. Okay, let me share the slides. Do you want the slides or something? Yes.
Uh, Unfortunately, the problem has not solved yet. I don't know what's the problem. I can share the file.
So it is possible that Jesse will share her desktop to everyone and you will go for the explanation.
The
Okay, now it is already shared with everyone, just let me go for the explanation will be good.
uh-huh.
I think it's working well now.
Mr. Yassi, because I'm host now, but I can share it. I can uh, I can control the slide. Mr. Yassi, you share the slide. Who shared the slide?
Mr. Jesse, I think so.
Mr. Yassi, you share. Okay, very good. Can I ask you to go to slide number 2? Very good. Thank you so much. Okay. As you can remember, I told you the forecasting is the process of the predicting a future event. Okay. For example, when thank you so much, Mr. Riyasi. Uh, when you when operation manager wants to predict the demand, the sale for the future, for the next month, next year, to next year, and also something like this, they can use the methods for predicting or forecasting. The underlying basis of all business decisions is for production, inventory, personnel, or facility. For example, when the company is going to um, produce products or offer services to customers, they want to know how much or how many inventory or, for example, personnel facility they should prepare or provide to produce the a specific quantity of the products, or also the preparing the services to offer to customers. So they can use the forecasting methods to make easier for them. Yes, this is forecasting. So the forecasting methods can help the operation manager to decrease the cost and prevent the producing extra product that can make extra cost for company. So, Mr. Yossi, please go to slide number 3. Thank you. The forecasting time horizons can be divided into three category, three period: the short range forecast, the medium range forecast, and the long range forecast. The short range forecast is up to 1 year, generally less than 3 months. If generally less than 3 months, we should focus on this sentence. For example, for 1 month or 2 months or the maximum 3 months. Of course, it can be up to 1 year, but it's better it's less than 3 months. For example, the activity that can be done for short-range forecast can include purchasing, job scheduling, workforce level, job assignments, production level. For forecasting something like this, operation managers can forecast for short-range forecast. For example, up to 3 months later. For the medium-range forecast, the operation manager forecasts 3 months to 3 years later. For example, sales and production planning and budgeting are the activities that operation managers want to forecast. They can use the medium-range forecast. In the long-range forecast is the more than 3 years. The new product planning, facility location, research and development are activities that can be put in long-range forecast. Next slide, please. Okay. The type of forecast can be divided into three: economic forecast, the assets business cycle, inflation rate, money supply, housing starts, and something like this. It's related to economic forecast. Technological forecast is the predict rate of the technological progress, impact development of the new product. For example, operation managers should know the technology, how the technology are progressing or are going in the market, and according to them, they should make decisions to bring the new technology in their company and use the new technology. Because if they cannot, if they are not able to forecast the technological progress rate, so their rival or their competitors can surpass them and can excel them. Okay, so the demand forecast also the predict sales of the existing products and services. And also another type of the forecast is the demand forecast. The demand is the predict sales of the existing product and services. For example, when the company is producing currently is producing some products, some goods, they should predict how much demand they will have, for example, in next month, in next year, next season. And according to the demand, they can prepare the raw material, personnel, and facility to produce the better quantity. 7 steps in forecasting is: at first, the operation managers should determine the use of the forecast, because they should make sure themselves they need to use the forecast method. And after that, they should select the items to be forecasted. For example, they want to forecast the implementation rate, demand, sales, or something like this. Which items should be forecasted? The third step is to determine the time horizon of the forecast. For example, it should be forecast for short range, for medium range, or for long range, and then select the forecasting model. Gather the data, make the forecast, and validate and implement results. And after that, they should gather the data. The data can be historical data. For example, the last month's sale, last month demand, because the last month's demand is clear now. The month has finished, and they had the specified demand for the last month, and this quantity is clear. They can use the historical data, for example, the 2 months ago, the 3 months ago, and according to this historical data, they can predict the next month or next year and something like this. This is the next slide. Forecasting approaches. Yes, qualitative methods used when situation is vague and little data exists. When the little data exists And for example, company wants to predict the inflation rate for next month to 2 months later, but the historical data is very little and they can access to more data. They can use the qualitative method. The new, for example, for new products or new technology, because for new product, new technology, the historical data is very little, and they cannot access to them because they want to produce the new product, new goods, and they have to gather the new data for this, and so they can use the qualitative methods. The qualitative methods involve the intuition and experience. As you see, operation managers wants to, for example, if wants to predict or forecast the demand for the new technology or new products, the teams they have not access to historical data because they want to start a new product in market. They have to use their experience and intuition to forecast sales on sales product and sales their product, for example, on internet or face-to-face in market. Next slide. Quantitative method. Quantitative method is used when situation is stable and historical data exists. When everything is stable and everything is going stable in market, and the historical data exists in hand of the operation manager, they can use the quantitative methods, existing products, the current technology, and involves the mathematical techniques. In this chapter, we use the quantitative methods, and we want to offer. I want to offer you and teach you the quantitative methods, and I want to tell you how can you use the quantitative methods to predict or forecast them some items in future. Next slide, please. Moving average. Moving average method is one of the good and useful method, and is very easy. Is a series of the arithmetic means and used if little or no trend exists in historical data. When you are using the historical data to predict, for example, next month, the moving average is very good when there is no trend. When between the data you can find a trend. For example, you would find that there is a trend between the historical data. You can use the linear method that I will tell you later. Now, but when you find that there is no trend, you can use the moving average method. Use often or smoothing provides overall impression of data over time. Moving average is sigma demand in previous periods, for example, previous months, previous years, previous seasons, divided by n. N is a standard. In a standard operation manager, n is equal 3 or 5. But you can use the another n period, for example. But a standard is 3 months or 5 months, 3 years or 5 years. N is equal 3 or 5 usually in operation manager. Please next slide. For example, the actual, the actual shed sales is clear. The January has finished, and for example, the sales has been 10, for example, everything $10 million, for example, or $10,000, or and the February the sales was $12,000. March the sales was $13,000. For example, company wants to forecast April. Okay, the January, February, March is clear. If the company wants to forecast the April, they can use the January, February, March, because the January, February, March has finished and the data are real. This is next slide. Okay, for April, as you see, this is enough. We use the 3 months. Here we can use the 3 months, and also the 5 months can be. It depends on you. 3 months or 5 months, as I told you, is our standard for operation manager. It's enough. We add with sum of the January, February, March, and divide it by 3. It's equal to 11 1/3. Okay. Yes. for May, it's enough we add up the April, March, and February. For June, 3 months before is May, April, March, and for July is June, May, and April. For example, we yes, it's enough we average the number. For example, for April, as you see, the 3 months before than April is January, February, March. It's enough we sum up the numbers divided by 3. For April, for May, April, and March, February, after when you predict or forecast the next month, when you should keep or you should save this number. When that month that you have forecasted finish, you can compare the actual or real sales with the months that you have forecasted. For example, you forecast for April 11 to on 3rd, but the real actual sale was the 16. There is error here because you cannot predict the 100%, and you cannot forecast the real number. You are telling we are predicting, we are forecasting. Forecasting is not real number. It's a number near to the real number. For example, 16 and 11 to 3rd have a difference together. When you when you want to calculate error, it's enough you if you reduce the actual number minus the predicted number. This number is the error for you. If when the error is less, yes, exactly. As Mr. Qiyasi has told, we need to say inshallah at the end of this period. When the error is less, it shows that your prediction was better. Okay, so when you want to use the 5 months, it's enough. For example, for June, you should sum up the January, February, March, April, and May together divided by 5. You can forecast this number for the June. For forecasting for every month, it's enough you sum up the 3 months before that month or 5 months before that month together and divide it by this. Please next slide. Yes, this is the actual sale after the end of the year. For example, in you can use the graph to say how much error you had during the year. You can draw the actual sales, and after that you can draw the moving average forecast together. There is a gap between this and this. You see, this gap is the error. We should reduce this gap and make the closer these two graphs together. Please, next slide. Okay. In the term projection, when the historical data, when the operation managers see there is a trend between the historical data, they can use the linear equation. All of you are familiarized with the equation linear. We have learned about it in the high school. The y equal a plus b multiplied x is the equation of the linear equation. Linear terms can be found using the it's enough. The y is the items that we forecasted, and x here is the months, the year, the for example 2 months later, 3 months later, 5 months later. We can put 5, for example, for predicting 5 months later, we can put 5 instead of x here. We can replace 5 by x here, and you can calculate y very easily. Y is the items that can be forecasted. For example, demand. You can reduce this accuracy when you, for example, by using of the moving average. When you calculate, for example, by using of 3 months, for example, you forecast the next month, okay, by use of the 3 months moving average. When you when you calculate these, but according your experience in comparison to last year, for example, you forecast for July. You forecast for July demand is, for example, 2,000 kilograms. 2,000 kilograms for your, for example, product. For example, okay. But when you forecast for July, the demand is 2,000 kilograms. But in comparison to your experience in last year, the July cannot be 2,000. For example, it's 2,500, 2,400. You can increase yourself this amount to last year's amount. For example, forecast instead of the for example, instead of the 2,000 kilograms, you can say it can be 2,300 according to your experience by last year's. Okay, and you can reduce according to 2,000, for example, 2,100 instead of 2,000. You have forecasted 2,000, but your experience shows that in July, the 2,000 is more than 2,000. For example, 2,300, 2,400, according to last year's. By ways something like this, you can reduce this error, and you can increase the accuracy. But there is no experience like this. You can use the moving average and produce according to moving average. Okay. Okay. Y equal is A and B should be calculated here. Everybody can hear me?
Okay.
What happens? Okay. A and B should be calculated here. Okay. Mr. DSC, can I ask you next slide, please?
Hello, can you hear me, sir?
Yes, sir.
Hello?
Yes, Mr. DSC. Yes, Mr. DSC. What about
Okay.
now? What about now? You can.
Yes, now it's all on again. Okay, I'll do it.
Okay, you can. Thank you. Please next slide. Yes. A and B should be calculated here. Okay. By using this formula below, we can use A and B, and after that we can calculate the linear equation. When you calculate the linear equation, it's very easy that you can forecast the next year, the 2 months later, to, for example, 15 years later, because there is a trend. When there is a trend, there is no problem, and you can use the linear equation. Please, next slide. A and B, A and B, A and B is a slope of the equation. You know about the equation, linear equation. We have, all of us have studied linear equation in mathematical in high school. A and B, for example, equation. Yes. This is the formula for equation, the linear equation. When you have a line in mathematical, you want to write the equation for line. You can use the y equal ax plus b. Y and x is independent variable. Y is dependent variable. A and b are two constant number. A and b should be calculated by use of the data. Okay. When you calculate A and B, you can use the equation of the linear. Every point on this equation can be located on the line that you draw on your book, on your notebook. When you draw a line, okay, by use of this equation, every point on this equation can be located on this line. Every equation has its own line according to A and B, because it's clear that we must calculate A and B. When we must calculate A and B, the equation for that special line can be calculated very easily. Sorry. Now we want to Now we want to solve the example together, as I know. Yes. Today we want to give you. I want to give you an example. Okay. Please let me solve this example together, and after this, I want to give you the more example and solve together. For example, if you see the example here, the year 2001, 2002, 2003, 2004, 2005, the electrical power demand in for example, in a power plant factory. In the power plant factory, the operation manager wants to forecast the demand for the after 2007. For example, 2008, 2010, 2015, 2020, and something like this. The electrical power demand is clear here. For example, in 2001, the electrical power demand was 74,000. For example, 74,000 kilowatts. In 2002, the electrical power demand was 79,000, and 2003, 80, 2004, 90, and something like this. X, okay, we should allocate to 2001, to year 2001, number 1. We should allocate to 2002, number 2. We should allocate number 3 to 2003. And time period. The time period is X here. Is the independent variable. For example, when we want, okay, so no, here is kilowatt. The electrical power demand is kilowatt. For example, kilowatt. You can use the other things that can be suitable for it. Okay. But here we imagine, we suppose it's the, for example, kilowatt. Because operation manager wants to how much kilowatt they should, for example, produce the next after 2007. The electrical power demand is Y here because it is the dependent variable, and independent variable is the year, 2010, 2011. So X is year and the Y is electrical power demand. For each year, we can allocate the year 2001 number 1, 2002 number 2. So the time period for X can be 1, 2, 3, 4, 5, 6, 7. Okay. For each year we do it. Time period is X and electrical power demand is Y. We want to calculate, operation managers can see there is a trend in this electrical power demand. For example, it's increasing day to day. Except in 2007, but 2001 to 2005, 2006, sorry, the electrical demand is increasing. When the operation manager sees there is an increasing trend in the electrical power demand, it will find that we can write a linear equation to predict the next years. X is clear, time period. X in power 2 in the another column. In the another column you see X in power 2 is 1, 1 in power 2 is 1, 2 in power of 2 is 4, 3 in power of 2 is 9, 4 in power of 2 is 16, 5 in power of 2 is 25, 6 in power of 2 is 36, and 7 is 49. Okay, this is X plus X in power of 2. Sigma X plus 2 is equal to 140. As you see in this example. Okay. And also you should sum of the Y, all of the Y or all of the electrical power demand, sigma Y. Sigma Y is equal to 692 kilowatt for these 7 years. Sigma Y divided by 7, because there are 7 years here, okay. Sigma Y divided by 7 is 98.86. Y bar is sigma Y divided by is the average of sigma Y. Sigma X is the sum of the time period. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is equal to 28. 28 divided by 7 is equal to 4. X bar equal to 4. And also Y bar equal to 98.86. We can calculate X in power of 2 and XY. XY is 1 multiply 74 is 74. 2 multiply 79 is 158. And also this is XY. We can calculate it in the separate column. The X is clear and the 7 is clear. The X in power of 2 should be calculated by us. Okay, we ourselves can make a new column and write the X in power of 2 in the new column. XY also can be calculated in new column by us because it make us it make it very easier and very better. Okay, now sigma XY is clear. Sigma X in power of 2 is clear. Sigma Y is clear. Y bar is clear. Everything has been calculated. Please next slide. Okay, by use of the formula B and A, we can the B and A can be calculated. Sigma XY is 3063 minus N is 7 because we have 7 years here. In our example, only 7. 7 X bar is 4. Y bar is we calculate Y bar how much 98.86. Sigma X in power of 2 is clear and N is Everything has been calculated and can be replaced in a formula. And A and B can be calculated very easily. It's enough that we know that X is the period and Y is the items can be calculated, can be forecasted. When you identify X and Y, you can calculate X in power of 2, XY, and X bar, Y bar, and everything like this. Okay, very easy. For your convenience, instead of we can replace some numbers with the year. For is X bar, the second column from left is X. Okay, you see, second column from left is X, time period. Time period is X. 1, 2, 3, 4, 5, 6, 7. We should sum of them. 1 plus 2 plus 3 plus 4 plus 5 is 28. X bar is sigma X divided by 7, because n is 7 here, because we have 7 years. When B and A is calculated, very easy. It can be done for all of the prediction, all of the forecast. When the sigma X, sigma Y, sigma X in power of 2, sigma XY, everything when calculated, B and A can be calculated very easy. B is 10.74 and A is equal to 56.7. Now we can write our linear equation. Please make a slide. Yes, the trend line is Y bar is equal to 56.7 plus 10.74 multiplied by X. If you want to forecast, for example, 2011, okay, 2011, because we have calculated the trend line. When you want to, please let me 1 minute. Okay, I will explain for you. When you want to calculate, for example, when you forecast for 2011, okay, 2011. How much is the 2011 is 4 years after 2007. Okay. When you the 2011 is 4 years after 2007, because we have the date of until 2007, and we have calculated to trend line. Please let me explain the 28 for students, and after that, Mr. Qiyasi, can I ask you come back? Yes. Please see the time period. Look at this second column, time period X. I'm explaining the 28. Where 25 comes from? Okay. Time period. Time period is 1, 2, 3. If you sum up all of this number, 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 3 plus 4 is 10. 10 plus 5, 15. 15 plus 6, 21. 21 plus 7, 28. Sigma X equal 28. We have 7 years here, so 28 divided by 7, because 2001 until 2007 is 7 years. 28 divided by 7 by n is X bar. X bar equal 4. If you see the formula A and B, see the formula B and A, okay, we need the X bar, Y bar, sigma XY, and sigma X power 2. X bar is the sigma X divided by n. N is 7 here, because we have 7 years. X bar equal to sigma X divided by n. And also sigma Y divided by 7 is Y bar, 98.86. If you see the third column, electrical power demand, this is Y, because it can be calculated, it can be forecasted. Every item can be forecasted is Y, period is X, time period is always X. The demand, the sales, and everything can be calculated is Y. When there is a trend, we can use this method. Okay, Mr. Qiyasi, can I ask you go to the next slide? Thank you, sir. The trend line is clear now because A and B has been calculated by us. You can write the Y equal 56.7 plus 10 from X. For example, if you want to calculate forecast the 2011, 2011 is 4 years after 2007. Are you agree with me? 2011 is 4 years after. Okay, it's enough. We replace between X for the Y can be calculated for 2011. For 2008, 2008 is 1 year after 2007. We should replace X by 1. X is the period of time. Period after the number of the period after the last period that we have calculated. For example, we have the demand for 2007. We want to forecast for 2008, 2011. For example, if we want to forecast 2020, okay, 2020, which number should be replaced with X? Anybody knows? If we want to calculate for a very good, Mr. Qiyasi, very good, 13. Because 2020 is 13 years after 2007. It's enough we replace X between 13. The Y can be calculated. Y is the electrical power demand for 2020. It's enough. You replace the number of years after the last years that we have here. Okay, very, very easy. So in linear equation, we should calculate a linear equation. No, I gave you an example. I gave you an example. For example, I gave you, because we have calculated the linear equation, okay? Now, because A and B has been calculated and we have, thank you so much, Mr. Qiyasi. The trend line or the equation line is clear now. Y is equal 56.7 plus 10.54 multiply X. 420, oh yes, if we want forecast for 2020, 2020 is 13 years after 2007. Because we have until 2007, yes? Now, the 2020 is 13 years after 2007. It's enough we replace 13 with X year. The Y can be calculated because we have the formula now. We have made a formula. The formula is the same trend line. The trend line is the new formula for these examples. Very, very easy. So at first, please let me explain. We should put it the time period X. The time period is always X, and the items can be calculated. It should be Y. For making easier, it's enough we allocate X in power 2, which X in power 2 should be yes, I know. X in power of 2, X in power of 2, X به توان 2. Please let me say the Farsi. Yes, X in power of 2 is X. No. X in power of 2 is X multiply X. It means that you should multiply X in itself. Okay. X in power to X multiply X, 2 multiply 2, 3 multiply 3, 4 multiply 4, 16, 5 multiply 5, 25. Okay, please let me give you an example. Please let me give you an example. Mr. Yossi, I passed the host to myself because I should share a slide. Okay, you can see the slide now, everybody. Months and sales. Everybody can see the slide. Okay, this is the same as the example. The example was the year 2000 until 2007, and the Y was electrical demand. Now the period is months year, January, February, March, April, and the sales, the Y is sales year. Okay, sales. For example, 34,000 US dollar. For example, 40 February is the 43,000 US dollar. The sales. Okay. Now you need to you need to make the new column. So the month is here. No. X is months. And Y is sales. Okay, exactly. You should allocate the number to months. For example, January is 1, February is 2, March is 3, April is 4. 4 is there, as I told you. The sales is clear. You need to make the new column to show the X multiply Y and X in power of 2. Now, okay, I give you few minutes. Exactly the same. It's exactly the same. Please calculate the trend line or the line equation. the month is X here, okay? The month is X here, and the sales is Y here. Because sales should be forecasted. So sale is Y. Y is dependent variable. Y is always is the items that we can that wants to be forecasted. And month or period is X. You should add the new column to calculate some items. For example, X multiply Y and X in power of 2. Exactly the same as the example that we have done here. But it was the year 2001 and 2004. Only difference is the month is here. And it was the electrical power demand is what we have the sales here. Exactly the same. You should add the column to this to calculate some items, to calculate A and B. When A and B are calculated, you can write the trend line. Very easy. If we cannot discuss about this, please write down this in at piece of paper. Please write down this table at your piece of paper. If we have not if we have not enough time to do this, please do it yourself at your home, and we can discuss the next week at first of class. Okay, if we have not enough time. Because I think we have not enough time, and the class automatically will be ended after the amount. Okay. Okay. So I want to ask you a favor. Please study this slide because I have sent the forecast to all of you. Okay, you have now all of the slides about the forecasting now. Please study it yourself because it's very easy. It's enough you see the slides, and after that, please solve this problem. Next week, we will discuss at first of class about this. Okay, because you are I think you are tired now, and may I think if I go ahead, you will be confused about that. But it's very easy. The month is X, the sale is Y. The January is 1, February is 2, March 3, April 4. Don't forget this. Okay. Thank you so much for everyone to participate in class, and I hope we had a useful class together. And if you have any question, please send me email. And I hope you will have a nice night and everything going well for you. Okay. Thank you so much, everybody. Please write down this table. No, Mr. Riafi, don't worry about that. Mr. Riafi, don't worry about that. Nobody saw your desktop. Yes. Don't worry about that. Okay. Everybody, goodbye and have a nice time. Everybody, goodbye.